Welcome everyone to this meeting today about the result sharing of the Federated Learning Testbed project that has been running at AI Sweden for about 6 months now. And just to have a nice and smooth meeting, we have quite a full schedule that you will see in a second. Please keep yourselves on mute while others are presenting. We will have some Q&A sessions and open up for questions. So either use the chat function or raise your hand and we will try to bring in your questions. But in most of the time, please keep yourself muted. You're welcome to keep your cameras on. But we are recording this webinar and we intend to put it up on AI Sweden's YouTube channel afterwards. So please be aware that you might be seen. And then, yes, that's basically everything, Eric. So I think I will hand over to you to show the agenda and also start the important stuff of this meeting, the content.
Thank you, Ebba, and welcome everyone. So my name is Eric Wilson. I've been part of trying to manage this project for the past year, since August last year. And the agenda for today is that we start with a more technical block, looking into some of the POCs and their results. And then after the coffee break at 10, we look more into a use case involving healthcare, and also a rather lengthy legal discussion that we think is one of the key discussions in this session, because it's usually a showstopper combining legal and technical questions. So with that, I intend to start with giving you just a background to why federated learning is so interesting, and then how we've been working with this project. So I usually show this slide, meaning that there's some frustration today because due to how machine learning is done today. The AI scientists or machine learning engineers, they want to do a lot of stuff with their data, but they're usually prohibited due to that mainly there's legal constraints, or they don't own the data, or the data is too sensitive. And that's because how to do machine learning engineering or modeling is that you need to centralize your data. And you basically can view all the data to manage it. And this comes with a lot of risks and issues, but that's how it has been done up until today. So the solution to this is then spelled federated learning, of course, which proposes a new way of working. That instead of sharing the actual training data to one centralized location, you enable access to your training data, so you rather share insights of the training data. Meaning what you share is rather the model weights that has trained locally. So the central person, the engineer doing one model, they don't see your training data. So this is projected or believed to start a lot of new discussions and collaboration opportunities. And the training cycles can be viewed as this, that you send out an initial main model to the devices and nodes. And here the devices and nodes can either be your phones, cars, if you're a car company, or base stations if you're a telecom company, or also what we call silos, which is, for instance, servers or computers at different hospitals. So there's two broad categories in this. You send out your model and then you train on the local data. And in step 3 or 4, you send back the local training weights or model weights. And then you loop step 2 to 4 until the model is ready. So that's how it goes in theory. And why this is so interesting is because it requires less bandwidth of data transfer. So for instance, if you work with video data, if you're a car company recording road data in Japan, based in Gothenburg, you need to send your engineers every day to Japan, go home, let them come home with briefcases of hard drives to store the data in Gothenburg. So instead, it's proposed that let the data remain on the edge or at the devices, and rather share the training insights. So with that, it's involved less costs and also a faster learning speed. And of course, it's one of the big factors is that we believe this is an opportunity to comply with the data privacy restrictions. You don't actually see the personal data, but you learn from it and you share the insights from the personal data. Another takeaway, sort of what I mentioned before, there's two main categories on this, and they have various sort of challenges. One is called federated learning cross-device, and one is called cross-silos. Cross-device is, for instance, Google, who has their Android phones, where they did like a few years back, they proposed or used federated learning to give a more personalized typing recommendation on their Google keyboard. So that involves millions of devices, and then cross-silo is, for instance, the healthcare use case I mentioned before. So when we set out to explore this new domain, we didn't know much August last year. So the main sort of vision or scope of this project was to explore this topic in a broader sense. How do you work with it? What is it? How do you work with data that cannot be shared openly? What is, for instance, can we develop best practices and guidelines, and what frameworks and softwares do you work with, what issues, and so on? And then create like what we call a test bed, which is rather sort of a shared environment where we share insights from all the learnings we did on the way. And some of the questions we had with us in was basically these: what knowledge is required to get started, and what framework do you use with what use case? How differ the performance of a decentralized model versus a centralized trained model? Do you need special hardware? And does it actually solve the data privacy issues? So many of these questions we have tried to answer and also answered during the project. And some of them remain unanswered because they're sort of bigger scientific questions that you cannot answer on this short time. So the testbed projects involved these actors. It was financed by Vinnova, and some of the actors here you see on the screen have been doing sort of parallel projects where we shared insights along the way. But the takeaway from this slide is that it didn't only involve the technical aspects, but rather the privacy and legal too. Because to us, we usually see that sort of as a showstopper or blocker, that you have a technology you would like to work with different organizations, but the legal department isn't always, doesn't really understand how it works. And the backbone of the project were a couple of POCs with one sort of umbrella project investigating the legal requirements for all the POCs. So starting from the left, one involved comparing performance of a NLP model created in a centralized versus a decentralized way. Another one involved healthcare sector. Can you take a model that is trained on centralized data and train it decentralized? So it sounds almost easy, but there's a lot of steps sort of to get the hospitals and management of those hospitals sort of to understand what it takes and also enable access to their data. The third use case was, can a car company train an object detection model on data stored in China, combine it with Europe, and do it legally? And then the fourth one, look into the sort of legal requirements of all these POCs. So final slide, we have a result page up where we are sharing links to the sort of so far results. But mind you that the project is ongoing for 1 more month and some of the reports are being finalized. But here's the QR code. And I also share the link in the chat where you can keep on getting back to this homepage for the coming weeks, where we'll update the links and the reports as soon as they're ready. Or you can send me an email if you're interested in any of the content. So with that, let me introduce our next speakers. So our next speakers are Shital from AI Sweden and Mina from Cesult that will talk about this working with data in China and Sweden use case, which involves rather data on birds. So Shital and Mina, take it away.
Yeah, thanks. Very nice introduction about federated learning. So, and also very exciting project that we were a part of it. It was a privilege. So now, as Eric mentioned earlier, we want to talk about like one of actually these use cases or pocket studies that we have done during the project. Yeah, I'm Mina Alibegi and I work at Zensac. And today, Sheetal and I will show you this demo that we have done as a part of federated machine learning. It was a federated object detection model that we done. And we used the Baltic Seabird dataset during the project to learn how we can use that actually later on for our road data at Zensac. So let's get it started. Yeah, one of our main purposes as Zensac is actually to make safe and intelligent mobility real for everyone and everywhere. So to achieve our purpose, actually, we need to collect a massive amount of data every day by driving our data collection cars all over the world. Since that's how we can ensure to have a continuous development of a world-class AD software. However, as was mentioned earlier, data collection and data transfer are not as straightforward nowadays, since like lots of data sharing policies are emerging every day. For instance, we have this challenge that the data that we collected in Europe, we cannot transfer that data in China, and the data that we are collecting in China, we cannot move it to Europe either. So because of the GDPR and also the policies that are in China. So then the question becomes how we can train our software still. Yeah, next, one more click, please. How we can still train our software from all data from all over the world, while we still comply with all this legal legislation. So we found that federated learning can be a solution to solve this problem. Actually, as was mentioned, it's a machine learning technique that in it different clients. It could be, as mentioned, edges or edge devices or data centers. In our case, it will be data centers in China and Europe. Collaboratively train a common model with orchestration of a central server while they hold their actual data locally. In this method, the clients only share the learnings or insight from data with each other. So no personal data is being shared this way, which can address the data privacy concerns in GDPR somehow. But beside this, actually, what happens is that we don't need to move the large amount of data around, so we can save bandwidth, but also storage while we can still utilize the learnings from such data. But more than that, also it opens up numerous opportunities, especially for us to shorten the development loop and improvement of autonomous vehicle software. Because then we can have access to a large amount of fleet data, which is a great opportunity. We can improve with all the data from all the cars all over the world and learn more faster about the edge cases. So we wanted to learn more about the potential of this technology and what are the steps ahead to make it real actually to solve our mentioned challenges and also gain the other benefits from it. So we participated in testbed in Federated Machine Learning Testbed project together with other partners, and we introduced this pocket study to reflect our challenges. It's called Hello China, as I have mentioned. And this Hello China podcast study is actually a real, is a cross-silo federated learning. And what we wanted to learn from this project was that how federated learning can be used in real-mode cross-silo setting to develop machine learning solutions on data that cannot be shared openly between different data centers due to the legal legislation. But also we wanted to see how is federated learning versus centralized learning. What is the real impact of federated learning? And also how the number of nodes, the distribution of data and such can affect the performance of the federated model. So to answer these questions, we use this FedBird dataset that was donated to AI Sweden by SLU. So the Hello China podcast study called also FedBird because the birds was in the project basically. Actually we run this project on edge devices available at Edge Lab at AI Sweden. And it's a great example for those that are interested to know more about the federated learning to get started with a real setup of it and try out new ideas. And different partners was in the project. It was AI Sweden, Zensight, Campcom, Scaleout, and Örebro University. And so let's see more details about first the dataset and then about the project. So this dataset is actually a real-world challenging dataset. And is a highly imbalanced data set. And yeah, it doesn't have yet any privacy restrictions because it's BERT, but we will see. And the data set is about 200,000 of video footage of guillemots that is collected from 2 different ledges in Gotland Island. And 1,800 frames from this video data is annotated manually with bounding boxes around the birds which are present on the ledge. And these birds are classified into 3 classes, like adult birds, chicks, and egg. And the amount of like birds belonging to adult bird class is much more than the other 2 classes. Yeah, next please. So in the federated setup that we have, these 2 ledges, each of them are considered as a data center or a client. Actually, one is called Parallel 3 and the other is called ROS 3. And each of these ledges are allotted with 1 edge device, like a Xavier processor that we had at the Edge Lab. And this processor is actually like responsible for training, like getting the data stream and also train the local object detection model on that data. And then also when the models are trained, sending those trained local models to another central server that we had at the Edge Lab for aggregating the learnings. During the project, next slide, please. During the project, we used a modular and open source federated learning framework called FEDEN This framework is developed by a Scaleout system. I think they are also presenting or talking about the project later on. We use this framework to communicate between the clients and the central server in this project. And in this framework, there are three main components. There are a reducer, a couple of combiners, and a number of also clients. And clients are the data nodes, which have access to the actual data, and their role is to train the the model on that local data set, and then also validate models on that data. And then the orchestrator or combiners actually get these trained models from different clients and then combine them, aggregate them into a single model. And these models are in turn forwarded to the reducer, and the role of the reducer is to take different models from different combiners and combine them into one single global model. All these incremental models will be available in this framework, but Cesult will give you much more details about this later on. For this project, we used actually a single shot object detection model, the tiny version of YOLO version 3, as the baseline model for object detection. And this model predicts the location of the bird in an image, and also the type of them as well. And we choose actually this model because it can support relatively small available data set that we had, and also it facilitates fast training on edge devices like Xavier processor. And we use the TensorFlow and Keras to implement the model, and also we evaluated the performance of the model with mean average precision. And the code of the project is actually available at github.se, GitHub of AISweden.se. You can go there and try out the project yourself. So now Cesult will show us a demo of the project running on edge devices as Sweden.
Okay, thank you, Veena, for setting up the context. Before moving to the demo, I just want to make it clear about the network topology that we have used as part of the Edge Lab. So we have two Xaviers acting as our client nodes, and the client nodes communicate with the combiner where the aggregation of the local models happen. And the combiner is also communicating with the reducer, and all the models are stored in a database so that we could get back to them later and evaluate them. So, and the framework that we're using is it's Fedin, and all our models are coded in TensorFlow and Keras. So let me quickly go to the demo. So here, if you see the reducer database and the combiner part, we have already set it up in the interest of time. So I'm going to, once I set that up, I could get the access to a dashboard like this, an interactive dashboard where I can actually start my federated learning jobs. So if I quickly go into the dashboard and see, it's written that here it shows that to the combiner I have only 0 active clients. That means I have not set up the clients yet. So let me quickly set up the clients and show you how to run one node. So here, one of my clients is already set up and it is asking for an assignment from the combiner, like a training job. What should I run? So let me do the same with the other client as well. Okay, sorry. Okay, now both the clients are set up. So let's see if it is reflected back in the dashboard itself. So yeah, now both of my clients are connected. So it is that easy to connect clients to the combiner. And once my combiner and everything is set up along with the clients, let's start few rounds of federated learning. So here, what we see is the active model is fedbird.tar.dz. So how it works in fedn is we send the code that we are going to run on the clients from the reducer. So this is to maintain concurrency between the clients so that the clients run on the same code. So once we send the code and also say that, okay, we are going to run a Keras model, we mention the number of rounds we want to run. Here in our code, one round of federated learning is where both the clients run for one epoch on their local data sets and send the models back to the combiner. And the combiner does the aggregation and sends the global model back to these clients. So that is one round of federated learning. So let's say I set up, like I say I run for 5 rounds of federated learning. I also mention a timeout. This is because one of our data sets is huge, which is around uh, uh, it has 90% of the samples, training samples. So this is to mention, this is to let the combiner know that it has to wait for at least 600 seconds to get both the models for aggregation. And then I say that please validate, and then I submit. So then it starts my training on, you can see that the training is started on both of my Xaviers. So it is as simple as that. And let me quickly go into the network and show you into the dashboard and show you some of the metrics that we can actually track. Yeah, so here we can track the training loss. You see that the loss is going down, so that means we have the model is learning. And we also can see and track the mean average precision across different training rounds. So here we see that there is a lot of difference between the mean average precision values of both the clients, and in at some iterations it kind of gives the same mean average precision for both the clients. So we took such a model, and then we actually tried it on a video from the test data set, and we see that it works something like this. So this is a global model. It is not perfect. There is a difference of accuracy compared to a centralized setting, but this is also much of it can be from the fact that we are using a tiny YOLO v3, which is not perfect in itself, but we have to run it on a Xavier, so we have used tiny model and not the full version itself. I will show now the final quantitative results that we got from this project. So in a centralized setting, when we have all the data set at one place, we got a map of 34.8. And when we had and we also trained models separately on the client data sets to see what is the map value that we are getting, and it turns out to be around 37.16 and 12.5 for the client 2, in which the data set is very small. But in the federated learning setting, when where one client has a lot of data and the other client has only 10% of the samples, we end up with a map value of 29.6, which is not same as the centralized setting. There is still a lot of scope for improvement. But an interesting fact here that we could see is that in client 1, we end up with a map of 32.48, but in client 2 the map increases from 12.5 to 26.89, which means that the insights that uh, the insights from the global model, which also comprises of the insights from the client 1, are used in client 2, and the map has been increased from 12.5 to 26.89, which is very interesting. We are also looking into how to make the federated learning setting map value as close as to the centralized setting, and we are trying different experiments, but we'll have all of this in the report that we are going to share in a month. So this is my final slide. These are the actors and participants who have made this project happen. And if you have any questions, do let us know or send us an email. So that's it from my side. Thank you. I'll give Eric and Ebba, please
Yes.
take it back. Yeah.
Thank you, Sheetal and Meena. Great work. And I think also a great POC to see taking shape over the past year. So I share the link for everyone in the chat, one to the Git repo and one to sort of the YouTube video where Sheetal and Meena a few weeks back did the same demo during the partner days. So our next speaker is Andreas Helander, one of the co-founders of Scaleout, who's behind FEDEN that Sheetal and Meena used. So Andreas, please.
Thank you, Eric. I hope you can hear and see me and my slides. Good.
Yep.
Thank you for that introduction. Yes, I'm Andreas Helander. I'm a co-founder of Scaleout. I'm also an assistant professor at Uppsala University in scientific computing. And I'm here to tell you about the work we have done in Federated Learning Testbed and a little bit about us and the framework. But just very briefly, Scaleout as a company, we were kind of founded in 2018. We're 6 co-founders with various backgrounds, both from academia and from industry, product development, and entrepreneurships. We have a strong focus on open source software, and we have a mission to advance federated learning or decentralized AI in general. So this is a little bit about us. We are a self-funded company, but with that means, of course, that we have great partners and customers that we are working together with that has really helped us shape our products in the last couple of 3 years. And here AI Sweden, not the least, has been very important partner in this for us. So what we have done in the Federated Learning Testbed in our contributions there has been, I would say, centered on helping do proof of concepts with the Federated Learning FEDEN framework that Sheetal and Meena just showed. So we've been heavily involved in FedBird in there with supporting the team there. We have also worked together with Peltarian and a great data scientist called Agrin Himshil on NLP model proof of concepts based on work that they had done prior to the project. And also, like, important part of this has been to develop and document reference deployments for EdgeLab. But I would also say that a big contribution for us in this project has also been to sort of share our expert knowledge on federated learning and help train partners and the team there. And Eric, there is also like documentation from us here in particular related to how you can deploy and size and scope FEDEN deployments, a little bit of the network behind it, what Sheetal showed, available in the AI Sweden Jira documentation system. So I'm sure Eric can help you, point you to the right places there if you want to read more about that. So a little bit about FEDEN and why we're developing it and what we are focusing on. So it is our open source contribution to the federated learning space. It's available on GitHub, and there is also a preprint available on Archive that describes the work in depth. We are focusing, I would say, in the architecture on 3 things: scalability, flexibility, and sort of production grade properties. So a big push there is related to scalability. This is why we have this tiered architecture model that Mina introduced. It means that we are able to scale out with many combiners, essentially, many aggregator servers, to meet both the needs of, say, geographic locality, but also like increasing pressure on the network if there are many clients. So in this paper there you can see us doing experiments with, say, cross-silo cases with up to 1 gigabyte model updates and 40 nodes, 40 clients spread over 4 regions in Amazon. And then you can see also, like with 4 combiners, you can easily attain network throughputs in the aggregation phase of, say, 450 megabytes per second. So that is pretty good. You can also tune the framework to do cross-device learning. So in the paper there you can see also us doing, say, a single combiner handling, say, 1,000 very lightweight IoT clients. So that's like a big focus in the research there, is like how can we by simply configuring and tuning the framework and deployments meet the needs for scalability in different settings. But then flexibility is also very important, and that is, we also set out early on that we need to be agnostic to the machine learning framework in use. We don't want a deep integration with any of them. I think that has been important, and also ease of use, that there should be minimal model redesign. If you have developed a machine learning model, you should be able to federate it with as little effort as possible. The other thing, production grade, what we mean there is that we are focusing early on taking it sort of to real world distributed deployments with enterprise security. So there is, you will not find a simulated mode in Fedden, but you will find distributed and pseudo distributed modes. So what we have learned from the project, I mean, it's been very important for us in developing this solution. So we were set out, of course, to look at sort of how this design access that we put out, how they sort of stand up in real world POCs. So we found a sort of scalability of Fed, and that meets or vastly exceeds all the requirements that we have seen today. But very interesting, this flexibility aim was really challenged by the FedBird project that we saw that brought yet unseen requirements on the model structure. So this has been very important. It really helped us generalize our solution. And also the production grade there, I think we have benefited a lot from working with EdgeLab to sort of validate that we are able to scale up from these pseudo-distributed deployments to real edge deployments. So that has been very good. But we also learned that in the interaction with the data scientist teams in AS Sweden and also in the partners, like the setting up the business logic around these federated projects can be conceptually hard for new users. So I think we need to work with clear and concise terminology, for example, for how we describe a federation and the client code and initial model. And so there's many things there that can be that is important to have a common lingo around. We also see that DevOps complexity can lead to unnecessary misunderstandings, and that the model we have opted for with no simulation mode, what we learned is that it is very powerful for going from simple proof of concept to, say, live deployments in EdgeLab and other environments, but it also introduces conceptual overhead. We also saw that this UI that we have developed turned out to be very useful. So that is something we need to work more on. I think we bring all these insights that we learned into our current work on something we call a Scaleout platform for end-to-end decentralized AI. So this is a software as a service that we're building with the purpose of making it much easier and faster to take proof of concepts, to do proof of concepts, but also to put them in real production end to end, where you can also sort of serve the federated model and you can interact with clients and data, like essentially the open source toolbox that you need as a data scientist to conveniently work with federated projects. And this platform, I'm happy to announce as well, is now in private beta, so it's possible to go to our webpage and sign up for early access. And here we are, of course, very grateful to the Testbed project. It has been, as I said, very, very good preparation for this. So just I wanted to comment a little bit on where we see the field or where we see technology is heading. And this slide here, what I'm saying here is that I think that federated learning is graduating from university in 2022. And with that, I mean, in no ways that research is done. Much more research is needed, but we are seeing a clear maturity, both in the academic side and in the industry side. And with academia, I mean that we are seeing quite a large amounts of publications. There are more and more, say, incremental in nature, more focused on specifics. And this is a clear sign that the methodology is becoming more well understood. I think vertical federated learning is still a frontier that where a lot more research is going. We also see, like, increased adoption in enterprise, and I mean, it was clearly put on the agenda also in Google I/O recently. So I think that this is a clear sign that it's maturing. And this means that it's going to become an important component in something we call MLOps for the distributed cloud. And this is essentially the type of software that we're seeing today to put machine learning in production, but other, with special or focused on solutions that handles the complexity of distributed infrastructure like edge clouds and others. So this is that, and that goes both for their federated learning will be an important part in the training toolbox, and there is also techniques going to be developed for distributed or decentralized serving of models. And this is really what is going to put decentralized AI in production eventually. So this is important, and this is where we as a company are, focusing our efforts and committing to being a key player in this space. Just really quickly, a few comments on where you will find us next. So we are working in a project together again with AI Sweden and the National Library on, in the lack of a better name for it, towards a Nordic Federation for NLP. So we're trying to see if we can do language models across libraries, different libraries in different countries. I will not say more about this because we will have a separate session about that where the data scientists from the library can actually tell us about convergence results and so forth. But what's next for us? You will find us in different research projects. We are working on scalability and privacy for vertical federated learning with the air traffic industry in one project. We actually last week or 2 weeks ago, we got a new Vinnova grant that is going to look at privacy preservation features with trusted execution environments and various ways of trust and collaboration. We're also engaging with in several new commercial projects with, say, financial services, with European banks. There's an interest in using federated learning for quality control in manufacturing, and also, of course, autonomous or connected vehicles. So with that, I also wanted to take the opportunity to plug here that there is a lot of work to do to realize, to develop these tools. So we're actually hiring, so you should definitely reach out if you're an engineer or a project manager or in any way inclined to solve or put decentralized AI in production. So reach out to us if you're interested in what we're doing. And also a special thank you then to Mina, Shetal, Agrin and Erik. It's been a pleasure working with you in the project, and we really hope to be able to interact hands-on in various constellations in the future. Thank you.
Thank you, Andreas. Great presentation, and also for me, who've been running a startup, a great ask. A clear ask if you want to work with this. Andreas' company is currently hiring, and I think he will paste the email in the chat afterwards. But we need to, unfortunately, quickly move on. Also, Andreas mentioned vertical and horizontal federated learning, which are two key technologies that I didn't mention. You can Google them, but they're quite important in terms of how they work. So for our next speaker, if I'm back, let me introduce, let's see here. Evgenia, you can share your screen. Thank you. So Evgenia, she's usually a researcher at Faculty of Computer Science and Technology in St. Petersburg. And she'd been part of co-writing a white paper where they compared different federated learning frameworks and how they perform compared to each other. So please take it away.
Hello, could you see me, my screen, and hear me? Yes.
We see and hear you.
Okay. Okay. Hello, dear all. I'm very glad to present our results in analysis on the benchmarking of the open source federated learning frameworks. And here you see our team. I'm a team a research member of our team of Smotilyzer, and I'm a representative of Electrotechnical St. Petersburg University. So just a very brief overview of federated machine learning concept that Eric have already presented us. And I just also focus on some key elements or key features of federated machine learning and data partition in particular. We think it's quite important feature. So data partition defines the scheme, how the data distributed across how the data and their attributes distributed across clients that are collaborating within training process. So now our goal of our analysis was actually to understand the current status of open source federated learning frameworks and to assess their capabilities. So here the list of the open source frameworks that we analyzed and assessed. And the next, it's quite large, I think. So it includes PySIFT, Pedal Federated Learning Federated, a technology named TensorFlow Federated, 2 commercial frameworks. And we also briefly reviewed FeedN that was presented in the previous report. And here the key findings, you may see them on our slide. We highlighted by the green color the most interesting features. So you may see, but I want to notice that currently only two frameworks have released versions. This is a federated AI technology enabled FATE and PFL federated learning. Apart from the release version, they support several aggregation strategies for several analysis models, and what is interesting, for different types of data partition, for horizontal and vertically partitioned data. So they also propose additional privacy preserving mechanisms such as homomorphic encryption, multi-party secure computation, and differential privacy. That is why we put our focus, primarily focus on these 2 frameworks and implemented a series of experiments with these systems, with these frameworks. So here on this slide, you can see the the settings that we used in our experiments. We used the Google Cloud Machine with following parameters. We varied their number. So they acted as the clients, and one of them was assigned as a server that implements aggregating function. We varied their number to assess the impact of this parameter on the overall training process, on its accuracy, time, and network performance. And though the number of machine is quite small, we noticed that even such insignificant changes in the number can have a severe impact on the overall performance of the frameworks. The data set that we used in our in our experiments is our data set that describes the movement of industrial vehicles. It is available on the Kaggle site, so you may take a look at it. It is an imbalanced data set and contains approximately 1.5 million of records, and it was split during our experiment. So we assessed the performance, we assessed accuracy, training time, and network of the frameworks. We also implemented a series of experiments for horizontally partitioned data and for vertically partitioned data. To do this, we just changed the distribution of data and data attributes across the collaborating clients. And the next few slides will be devoted to the results which we obtained for the horizontally partitioned data, and then we move to the vertically partitioned data. So first of all, the best results in terms of accuracy we obtained for the gradient boosting decision trees that are implemented in FATE system. So here you may see from the diagram. However, this strategy is not very good in time performance. The training is quite long. However, the worst case in terms of training time belongs to the differential private stochastic gradient descent strategy that is implemented in PFL system. This is a differentially private strategy, and in fact, these results were quite surprising for us, and we explain such poor performance in training time by the peculiarities of internal implementation of communication between clients and aggregating server. This also results in a very high network between clients and servers for this strategy. So the network traffic also depends on the number of clients that are involved in the training process. So very similar experiments we implemented for vertically partitioned data. Processing of vertically partitioned data is supported by both PFL system and FATE Federated Framework. Both of the systems require require finding intersection of data sets that belong to different clients. But in our experiments, we used pre-aligned data sets. That is why this operation was not assessed during our experiments. To process vertically partitioned data, PFL and FATE use different approaches, use different strategies. For FATE, they solely rely on homomorphic encryption to perform processing of vertical data, while in PFL, secure multi-party computation protocol AB3 is used, and this difference actually results in the performance of the systems. So PFL shows better accuracy and better results in training time. Network performance for both strategies is not very good, and for FATE, the generated traffic exceeds gigabytes. FATE supports training also linear models for vertically partitioned data, for linear regression, for logistical regression, and but the performance, the accuracy depends on the number of epochs used to train these models and the clients, and you see that the accuracy increases with with the increase of iterations, but traffic and the time also increase significantly. FATE also supports training ensemble of decision trees for vertically partitioned data. And here they use homomorphic encryption to perform this training, to unite data from different clients. And here we can see that again, we observe increasing time and traffic when training ensemble of models that depends on number of trees that are in the model, number of clients participating in the collaborate training. So just brief summary about FLS framework and FATE framework. The detailed summary is presented in our report. It is already available as far as I know. That both systems support different models, different strategies for horizontally partition data. They implement federating and secure aggregating strategies for horizontal data. And PFL provides additional privacy preserving strategy. This is differential private strategy, but it is not stable in terms of network traffic and time. The accuracy is comparable to federating and security aggregating strategy. FATE provides various analysis models and various aggregating strategies. It even provides clustering, possibilities to implement clustering in federated mode. However, it uses encryption to secure data, and this results in large network traffic and significant training time. So our generic recommendations, our final recommendations, they are presented here on this slide. So what we recommend currently, we recommend using security aggregation strategy for horizontal partition data when training neural network, because with a similar level of accuracy and training time, it provides additional privacy guarantees when we train the models. When selecting aggregating strategy and model, we need always keep in the mind the requirements and the capabilities of our network bandwidth. The accuracy depends on the number of rounds, number of aggregations, but this will result in the increase of network load. That's why it is necessary to find this balance. And based on all of our results, we currently recommend FATE because it demonstrated more stable behavior. It supports several strategies for both horizontal and vertically distributed data. And as a backend, it uses a TensorFlow for the neural network, and it has a good documentation that is actually important when you start working with a new technology and when you deploy a framework. So thank you for your attention. The detailed report is already available at AE Sweden. So thank you.
Thank you, Grina. Great presentation and great work. We think this work is extremely important since it's currently an ongoing, evolving jungle out there. What framework should you match to what applications? So I think we will recommend you to look at this report as you sort of decide your technical steps and stack. So great work and great presentation. Let me quickly introduce our next speaker, my colleague Kim, who's in charge of setting up something we call Edge Lab, which he will talk more about.
Yes, thank you, Eric. And I will try to keep this one kind of short because I know we're running a little bit over time. I will just share my screen here, or the actual PowerPoint. So, what we heard from the previous speakers, we have built up a test bed here at AI Sweden to facilitate these type of experiments and explorations. And as you can see in my shared view here, we started off with that we wanted real hardware, real communications, and a flexible infrastructure to do all types of federation experiments within. And I'm pretty happy to announce that we think we actually got it. It's expanding day by day, and it's getting more and more involved. Move to the next slide here. So what we've done here is to try and make it as easy as possible for every partner to engage and learn. Sorry. So what we've done is with the lab, as you by the way can see in the picture behind me, because I'm actually in the lab right now, is that we try to make it like Lego bricks or a candy store, where you can choose between data sets, environments, frameworks, what type of environment in terms of edge devices and cloud environments you want to run in. If you want to do the federation over wire, Wi-Fi, 4G or 5G, and all of this is to shorten the time to get to the learnings for the partners, so we can accelerate everyone together. And from this, we hope to get out as much knowledge as possible. And as we've already seen now here from Andreas, Evangina, and Cesult and Mina, it looks quite amazing. As a part of AI Sweden, we want everybody to share what they're doing, and in so accelerate everyone here together. The Fedbird demo that Cesult and Mina just presented will be available for any partner to try out and play around with. Same also goes for HPE's Swarm Learning Framework. There was actually an article about it published in Nature yesterday, so really interesting. We also hope to make more and more demos and projects that either are running or has to run available, so we can get a jump start, get going. And in the picture to your right here, you can actually see that there's a lot of things in the pipeline, and you are welcome to check out the wiki we have. We use Confluence to see what's going on, and if you find something interesting, contact them directly or ask us for an introduction. Maybe you can get something out of it together. And with that, I would like to really highlight the guys to talk to and girls. So Erik, who's the main presenter here, Ebba Jonsson Lindqvist, and me, if you want to engage. And you will then be assisted by the wizards, the team here at AI Sweden behind the lab that facilitates it. Also want to highlight that we really like to use Slack for chat, formal and informally, and Confluence for knowledge sharing. So I'm actually going to stop sharing my screen so you can see behind me. So here we actually have the lab, and it's very much real. The edge node are here to my right. The demo that Cesult and Mina just showed up is actually on these two nodes right here. If you noticed, IP number 4 and 5 are those right here. So it is running. Apart from the edge nodes, we have the environment where we host the virtual machines, and where we can also simulate the federated learning before you push it out to the edge node and run on real discrete hardware. Also, very fresh right now, up and coming 5G connectivity. These arrived this morning, so it's a continuous expansion. And yeah, you're very, very much welcome to engage. And I think that's all from me. If there are any questions, I will be happy to answer them.
Thanks a lot, Kim. So it's great to see how the Edge Lab has evolved in parallel with the project. So also you can reach out to me, Ebba, and Kim, but also if you're in the Gothenburg area where it's currently housed at Lindholmen, you can just drop by and we give you a guided tour. It's always nice to feel the hardware in real life, even though we live in the digital space nowadays.
And I really must say, Kim, it would look like a virtual background, but it's so cool that it's actually your real background. So come and visit the Edge Lab. Thank you so much.
I can also add here that apart from having the hardware behind me, it's also, we try to make it an interesting space to be in and compete with with the living room basically and the office at the same time. So workstation, sofas, and you can't see it right now, but official sponsorship from Red Bull. So
that's great.
Feel free to hang out or come in over VPN and utilize equipment and hang out in Slack.
Thank you, Kim. So with that, let me introduce our next speaker. So we sort of needed the break as a buffer because we've been running a bit out of time. So if you have questions, ask them in the chat as the talks are ongoing. But our next speaker is Mattias Olsson, one of the few AI professors in Sweden who's highly involved working with federated learning in the healthcare sector. So Mattias, please share your screen.
Let me first yes. There are many AI knowledgeable people in Sweden.
But isn't that the title, AI professor?
No, I wouldn't say that.
Okay.
I think it's the correct title in-house is information technology with a specialization in machine learning.
Okay. Almost.
Yeah.
Sorry about that.
No problem at all. Yes, let me share my screen and talk about a test case. Let me see, where do we have it here? Do you see that?
It's currently loading. There it is.
Yeah.
It's a PDF. Yeah.
Yeah. So this is a test case that we do with Region Halland and HPE. Okay. And so a little bit of background here is, so we are working with machine learning and in healthcare, we want to push what we call is the information-driven care concept, where we want to use data as much as possible to drive decisions in healthcare and in the end make a patient value outcome. We have, of course, realized that working with data in healthcare can be problematic because data is sensitive. So access to healthcare data is, of course, maybe a tricky thing. This has been dealt with in Region Halland. They have very good access to their healthcare data for research purposes, but at the current state it is that it's still you need to be behind the firewall in order to access data. And of course, if we want to scale up the information-driven care within the whole of Sweden to start with, then the federated learning strategy is an extremely interesting approach, because then we can use more and more of the healthcare data that is available in Sweden in order to come up with decision support tools, for instance. So here we wanted to test this in a setting where we actually want to use the HPE swarm learning technique within the Region Halland firewalls and try to see what would it look like if we within, at least to start with, simulate a federated learning setting. And as a test case, we simply took one of the studies that that has been performed at Region Halland, and in this case, it was training a machine learning model to predict a 30-day mortality in patients that has been discharged from the emergency department. So there is a study on it here, and we simply want to copy that study and see how it works in a federated learning setting. It's not a very complicated machine learning problem in that sense. It doesn't require deep learning, and it's using they tested a variety of different machine learning models, where artificial neural networks was one of them, but other things like decision support trees, support vector machines were also tested. It has a challenge, this data set, in the sense that it is very, very unbalanced. So in their study, they had, in the end, around 121,000 cases. They used 66,000 of these for the development and 55,000 for validating the model. But it only had 136 target cases because this was a classification setting. And for the validation, it was even worse. So 0.21% positive cases when you did the classification. So this will of course be can be tricky for the federated learning setting. And this is also one of the things that we would like to test here. And as I said, it's not very complicated in terms of the models used. It's tabular data, very 18 features, 14 binary variables, and the other 4 are just continuous variables. So no image data, no text data of anything. It's in that case, it's simple data. And the models used in the model were they tested a variety of different models, and this is also what we would like to do in the federated learning setting. And the first step is to do this within Region Halland, test it virtually, or also within Halmstad University. I'll come back to that. So that would be the first step to do this. And then, of course, in a second step, we would like to do this. So we do a real federated learning, so that we actually do the swarm learning techniques when we are sitting outside the Region Halland. So that would be a second step. We do not intend we will here use the swarm learning technique by HB to test how things work for this test case. The challenges here and what we want to do here is just to make sure that to be able to do this with real healthcare data in a regional setting behind and as a first step behind the firewalls, but as a next step outside, to actually demonstrate that we can use this on real healthcare data. So the next slide is not so nice in the sense that we haven't really done this yet. It is still work in progress, and the main challenges here, I would say, has been the approval process, getting approval from, and it's both the university. It may sound strange, but and the region. And doing this, and as I would probably also put a little bit onto the current situation with the region being occupied by COVID and everything, but approval has taken a lot of time here. I think we are the latest news from HP is that it's going to be a little bit easier to work with their model. So I really hope for that. We have had some small technical issues with the equipment, but I think that has been solved. So even though I've said this before, I really hope that we can start working soon with this, because for me this would be an extremely important step to actually say, okay, we are doing this with real data, real healthcare data, and it has been approved from the reading point of view legally that this is okay to do. So even though it takes time, I think it is important to actually make sure that it works, to say that, okay, we can do this, and this is important. I think that's my my little.
Thank you, Matthias. And to me, this is a great result anyway. Also, like what you suggested here, guys in the audience, that how you work with sensitive data is that you work with federated learning or swarm learning inside the firewall in a simulated way first, and then you convince the skeptics and show that how the technology works before you bridge the gap between the various firewalls. And here at Region Halland and Halmstad Uni, we had to sort of be in negotiations with the legal department, but also the IT department, who is used to handing out computers. Now they need to set up Linux servers, which is like a new type of work for them. So it's a lot of things that has to happen in parallel. That has been learning to me, at least. I don't know if you agree, Matthias.
Yeah, it is a learning process, and hopefully the next time we do it will be faster.
Exactly. This is the challenge of being the first mover. Great.
Okay.
Thank you, Matthias.
Thank you.
So with that, I hand the floor to my co-host, Ebba.
Thank you so much, Eric. And perhaps you can put up our slides again. We're now, so that was really a good segue from Matthias to the next topic, which is also focused on the legal parts of federated learning, because as you know, federated learning is really the hope to solve the privacy issues that we have with sharing data, etc. And so a legal work package was created for this project to specifically look into those questions. And I want to introduce some of the people who have been working on this work package. And we have Linn Samuelsson from Max Law Firm. We have Olof Mogren from RISE and Josefin Remsgård from AI Sweden. And I have also been part of this work. So if you guys want to turn on your cameras, that'd be great. And just before we start this discussion, we'll have about 10-15 minutes where we talk about and elaborate on the work we've done. And then we'll let you guys ask some questions. And also maybe if you want to speak up or use the chat function, we'll see. But we will let you ask some questions, and hopefully we can give some good answers. But just to give you the standing point of where this report that we are now working on as a result from the research we've done, the report will hopefully be published in the end of June is the plan. Sorry, Eric. So your shocked face. End of June is the plan. And of course it will be published through AI Sweden and shared. So you can look forward to some insights there. But what we have been looking at, you can see here on the slide, is really on the input privacy aspects of federated learning. So basically looking at the model parameters and the question if the parameters can carry any personal data in the sense of the GDPR. So could the model parameters actually carry some data that you could see as personal data? And what would that then lead to? Or can we actually say that no personal data will be carried with the parameters, and it's really fine to use federated learning? So this is what we have looked deeper into. And please, panel, I'm going to try to see if I can see you all. But Linn, for example, looking at this specific part of where the model parameters and what can be carried in there. Can you also elaborate why it's important in regards to GDPR? What have we been looking into specifically here?
Yes. Hi, everyone. Great to be part of this today, and enjoyed all the presentations earlier on also. Well, because we don't, to put this kind of in context, because we started looking at the issue from the perspective that federated learning obviously is a big step in the right direction when it comes to privacy, since we're not sharing and moving the data. We are aware that there are several aspects of this, and not just the GDPR and personal data, but we know that personal data and the GDPR is a headache for much of the machine learning business, and different solutions for that. So that is why we decided to look at this specific issue in the legal work package. And the issue is that if we move training data as such, and that data includes personal data, we will be processing personal data, and we have like everything, all of the GDPR applicable to what we're doing. If we don't move personal data between organizations, then we don't have that problem. So we're hoping to see that federated learning, meaning that the training data itself is not moved, but the parameters as such, that would hopefully avoid moving personal data, and we could leave that GDPR aspect, and you wouldn't have to talk to us lawyers for that part of it. But then a bit disturbing to us, there are research that shows that training data, although it's not moved as such, but it can be in some cases recreated from the model parameters, and that could then potentially cause a problem. And that has been addressed in other papers that, well, so it is not a complete GDPR safe way, and we can't be sure that we're not moving personal data. So maybe we still have to consider all the aspects of the GDPR. And that we wanted to look into, because spontaneously we thought that that can't be reasonable. We can't really, it can't be that we need to look at it like that for every case. So that was what we wanted to look into.
Thank you so much, Lynn. And we'll get back to that question in just a short while, but I would like to let Olof just elaborate a little bit on this, how we can reconstruct data, if you can talk a little bit about that.
Sure. So in all machine learning, the learned parameters take or are affected by the training data. That's just how it is. Now, a lot of things affect how the information gets coded from the training set into the parameters. And in the federated learning, we have these local trainings where we train stuff in the local parameters, and then we distribute or we communicate the updates to these parameters to a central server. And that's generally where you start considering, is this private or is it not? One important thing is to just consider, who are we trusting here? Are we trusting the central server? In that case, we don't have a problem. Are we not trusting the other parties in the federated learning setup? Then we need to look into, is this private or is it not? And a lot of things affect how much of this information is in the parameters and what can be reconstructed. There is some work showing that you can reconstruct. It's called membership inference attacks, to see whether a certain data point is part of the training data. That works both for federated learning and for other learning. It's generally in a very limited context where you can recreate stuff. But we need to make sure we're not there. We need to make sure we're not in the case where we can recreate data, because in such case, well, that's when the GDPR comes in, I suppose.
Thank you so much, Olof. It might be you that have a little bit of sound from your desk, maybe. We heard most of what you said, so no problem. But just see if there's some scratching sounds.
Okay.
But so, Josephine, if we turn to you as the legal coordinator of AI Sweden, you have also worked a lot with this report and in this work. And Lynn was mentioning that we can maybe look at that data that may be retracted. And within the GDPR, we need to be careful with moving personal data that shouldn't be moved. So how do we get to having model parameters maybe carrying data and to doing the analysis of what is personal data?
Yeah, so we've learned in multiple projects at AI Sweden now that it's very valuable to have like the technical knowledge and legal knowledge or the legal competence working closely together. And here it is a definition matter, you could say, of like when does something become personal data? And it quickly becomes very technically advanced. So it has been very valuable to actually, when making legal assessments in relation to the GDPR, to have Olof to ask like really like looking into the technical aspects of what is really happening in terms of different technical terms, to really make the assessment of whether it is personal data or not, and how that assessment is made, what type of parameters or things could be like leaning towards personal data or towards like having anonymized data. So we've learned that there are different aspects that could be that are important to look at when making these assessments, which we will elaborate on in the report. So I would really encourage you to take part of the report to find some aspects of what could be important when making this assessment. But essentially it's about being aware of the questions. So even if GDPR would not be applicable for the transfer to the central server, it's very important to look at these questions and make sure that you have your assessments and documentation in place for how you've looked at these questions in terms of the technical aspects and the federated learning that you're doing, basically. So I don't know if that was a good answer to your specific question, but it's
it was a great answer to the question, and also a good tip there to kind of document the work you do, the assessments that you do, because this is somewhat needed to comply with GDPR. So thank you so much, Josephine. And I wanted to ask if Lynn can kind of elaborate on these assessments or like the technical details that can help you or not help you when assessing, for example, the data sets being used and the technology in the legal aspects.
Definitely, because I think maybe just for everyone a brief that input that, I mean, whether something is personal data or not under the GDPR, what we look at is how difficult it would be to link that data to a person and actually get that connection. So that is why we're talking about it in that technical sense. Therefore, a lot of the issues are about how difficult or easy will it be to make that connection, because believe it or not, but the legislation actually does give us some room to consider that. And so that is what we've looked into, and I would be happy to talk about it. I call it Olof's items, but because he's really great on these issues. But it's what we look at, for example, is what type of data sets. I mean, are we dealing with personal data from the start, and how much is personal data? What type of data? I mean, how big are the data sets? Because we've learned from Olof and also those the research, the article I saw here, Eric shared in the chat. I mean, how easy it is or difficult to recreate the training data. So different aspects that would make it more difficult to recreate it. Is it text or images? And also one thing we think we should consider is in what setting are we sharing this data? Is it a closed setting where we can't really expect that any party taking part in that setting would make an attempt to attack the parameters to find out the local training data? If that is completely unreasonable to think that, then I think that is also an aspect that is in favor of our assessment that it's no longer personal data.
And I think that's really what you pointed out right there, Lynn, the kind of the proportionality of these assessment. How reasonable is it to think that an adverse attack will actually find personal data? Because it's one thing that it finds data, and then how easy is it to actually see that it's also personal data that can identify a person? So you step in to understand the assessment. And Olof, maybe you want to just elaborate a little bit on those or things that you need to look into, for example, the size of the data set, for example.
Yes, so we have a little list of stuff that's from the literature of sort of, it's not from me, it's from the literature. So this is the size of the local training data set is one of those things. If you train on more data on the local node, then you sort of, each data point will be hidden in a larger context, sort of hidden in the crowd. So that enhances your privacy. Then some other things we have identified is the complexity of the model. Larger models make it more difficult. Also your step size in the updates. Larger updates make it more difficult. There are also techniques that you can combine with the federated learning, and in some settings, I think that's going to be the go-to method. So looking at differential privacy, which can be combined, such as differentially private stochastic gradient descent, also anonymization and pseudonymization can, of course, sometimes be reasonable, but I don't know when to use what. I think that's a little bit of common sense as well. Would you agree?
I'm sure Josephine has a comment to that. And I want to encourage, if anyone from the audience wants to ask a question, you can either raise your hand. I see you, Andreas. I'll give you the first word after Josephine.
Great. Well, yes, I agree. I think the important thing is being aware, I think, is the summary, and also including, like, even if you have an idea that this federated learning setting will be reaching these goals and having privacy, I think it's a good idea to still include a legal competence early on, to just make sure that you've highlighted the questions that are relevant for your specific case. So that would be my takeaway from the paper. But I think that it will be very depending on the data and the type of project and what you want to achieve and which parties that are involved. Yeah.
Bring in the lawyers early on. Major takeaway. Thank you so much, Josephine. Andreas from Scaleout, please.
Yes, I have one question for Olof and one for the lawyers, if I may. So the first question for Olof, I just wondered if you could elaborate a little bit on the sort of attack surface in these models. So if I understand it correctly, essentially these attacks depend on access to the parameters in the trained global model. So do you think that are there more or less sensitivity here in a federated case, or would any model be equally susceptible? I mean, even a centrally trained model to this type. I mean, this is the output privacy part, whereas federated learning is working with the input privacy.
I think you're right.
Yes, sorry, just to follow up there. I mean, can you speculate on, is it better to say apply differential privacy on the output side, restricting use to the model, or doing it as part of the training process during, say, aggregation? But that's a hard question, but if you want, you can speculate.
It is. I think there could be signs showing that I'll start from the end here, that it could be a good idea to look at the differential privacy early on in the process, because there are techniques there with differential private stochastic gradient descent, for example, where you add the noise already in the gradient updates locally on the client, which means that everything after that will be sort of guaranteed by the differential privacy guarantees, and then that's a nice feature, and it seems to be performing fairly well. as well. I don't have experience on the output privacy, but my preconception would be that you adding more noise in the output will also suffer. The performance will suffer, I suppose. Yeah, could suffer more.
What I don't understand there, I think, is the sort of if the I mean, that must also means that the parameters in the trained model are somehow not the right ones, in the sense when you have, I don't know, it's a tricky question, but yeah,
it is, and perhaps you're on to sort of the idea of generalization here, because the goal with machine learning is that we want to generalize, and if we are generalizing correctly, then we're not memorizing stuff about individual data points. So that's definitely the goal all the way.
Very good point. And then my question,
but sometimes it's we don't get there, and sometimes we do memorize stuff. And your questions about is it more susceptible in the federated setting than with centralized training? Was that correct interpretation of your question?
Does it matter? I mean, or is it only a property of the?
It doesn't really matter, because you analyze it in the same way, and you train stuff. I mean, the local training is a normal training. The only difference in the federated setup is where you aggregate stuff. The attacks that's been studied in the literature, that's on the updates that are sent from the client to the server. So given access to those updates may in some cases give you some insights about the training data on that particular client.
Yes, there is a larger attack surface than if you train in a centralized cluster, maybe. I see.
Well, Andreas, your question for the lawyers, and then we'll move on to Mattias after that.
The question for the lawyers would be that does it matter from the legal perspective how computationally expensive it is to do the inversion? Like if you can do a membership inference attack, but the computational cost is provably extremely large, does that have any implication on the legal side?
Yeah, the short answer is yes. Yes, from a GDPR perspective, looking at the definition of personal data, it's if it's an identifiable natural person, that's what we're moving towards here, because it's not an identified natural person, but can we, by other means, find out personal data? And if it's technically, financially almost impossible, then no, then the risk is so small that it's not regarded as personal data. And that is kind of like the key point, because then we don't, I mean, obviously we still need to care about the data and be cautious in other aspects, but we don't have to consider the GDPR. The data is then considered as if it would be anonymous. And, with anonymous data, with that kind of like statistics, you don't have to be as careful. I mean, then it's another type of data. So that is the whole point of this. So therefore, that aspect is definitely important. And I don't know, Josephine, if you want to fill in, I think this is one of your...
No, I think that was... The term is all the means reasonably likely to be used by the controller or by any third party. That's sort of the term that we are looking at. So that, of course, includes both the technical difficulty of re-identification and also costs. And there are multiple additional aspects that you can look at in terms of the argumentation towards or against, of course. Yes.
Thank you so much. And thank you, Andreas, for those questions. We'll let Mattias ask his question, please.
Okay, thank you. First, I would just like to say that I think this is a very interesting discussion. We have this discussion now in the federated learning setting, but since we have learned that it may be possible to find out sensitive data from the parameters of a trained model, the discussion then can be moved outside the federated learning, and we can simply ask, of all the products that is actually out there already that are based on AI technologies, have this issue been raised before? Have they been tested on the GDPR setting? just for the purpose of trying to see if there are sensitive data within the models.
And I'm sure you might have an answer to that because we've been discussing this a bit as well.
Okay, yeah.
Lynn, do you want to start with, for example, the other articles that we've read on the possibility of data following, and we've seen one article where they kind of very fast state that GDPR would be applicable. So that's part of the reason why we wanted to look into this. Any comments, Lynn, on that?
Well, I think, yeah, we're kind of gathering these issues and getting to the point. And not really, I mean, what we reacted to was that it was, yeah, that it's so easy to be overcautious in this case. We need to be cautious, but I mean, we can't be like overcautious. And also now we have other like proposed legislations within the EU to have a look at, so we can maybe get some help from there to see what kind of setup would help us in adhering to the GDPR with this. But kind of to actually, I mean, put some focus on looking at these issues with the technical perspective, how difficult, like what Andreas raised here, like, is it crazy expensive? Then, I mean, what is it? It's not reasonable to think that anyone would go about that. But I mean, what the question was about existing products, I don't really, I mean, I'm not sure, but I can't imagine that this has been in that type of focus. But I don't know if any, I mean, if Olof has any more input on that, or Eric, but no, I can't say.
Josephine,
But I mean, privacy is a big issue as such, so it's more maybe a general issue, and also not, because that is also an important aspect. The privacy of the GDPR aspect of privacy is what we're focusing on here, because I mean, as lawyers, this is something that we get all the time, and we want to kind of, yeah, help in that discussion and move this forward. But obviously there are other I mean, reasons why you wouldn't share your data. Like, it can be restricted for some other reason. I mean, with the healthcare, it's other limitations as well. And you could also be bound by secrecy obligations to a business partner. Maybe it's your business secrets internally in your company, so you don't want to share it. You don't want to risk it being spread. So there are other aspects as well.
Thank you so much, Lynn. And we will move on to the next part of this this meeting. But I see that there are a few questions in the chat. So Lynn, Josephine, or Olof, please feel free to type in some answers to those questions. But I think we want to send a message that these questions are very, very interesting, very relevant. Our research has not been like complete or covering the whole spectra of what could be discussed here. So definitely more research and discussions would be needed. So we just encourage participants in this meeting to reach out and see what we can do as a next project to look further into those questions, or at least collaborate on finding good interpretations and ways to move forward in this. So thank you so much, the panel, for this, and we'll look forward to having the report published quite soon. Eric, I'll hand over to you.
Great, thank you. And with that, I'll quickly introduce my colleague Athir, who is in charge of our decentralized AI program. And we'll talk more about how we see this moving forward. Athir.
Thank you, Eric. Let me share a couple of slides here. Just this account. All right. Okay, so I'm gonna talk about decentralized AI, and I will actually start by clarifying the notion of decentralized AI. It is actually what is started to be referred as federated learning. So when federated learning was initiated, it was about a paper in 2017. And that was really about decentralizing and preserving privacy. Somehow the term federated learning got attached to that specific method that was introduced in this paper, and we want to be more clear that it's more than one method. I know it's different, people perceive it differently. So we chose to be more clear and call decentralized AI. So we actually looking at this problem in a broader term than the established term in academia for the last 3-4 years that was attached to that specific methodology. And I think you've heard here all the motivations for why having things decentralized or federated, as the discussion has been. It's there are privacy issues, there are regional policies, there are communication limitations, but there are also computational limitations, and that's why you want to decentralize things. An example is like all mobile apps that collect data and provide services for us that are improved based on our data are applications where things need to be decentralized to preserve privacy. We have heard a little bit about, for instance, how in healthcare that you need to preserve some privacy from patients' data, and that could be maybe it's okay to use it in a hospital, but maybe between two hospitals is not possible, or even between regions it's not possible, or even countries. We heard a little bit about communication limitations. For instance, when it comes to autonomous driving, we'll have millions of cars driving. We want to train these autonomous cars. It's a lot of video data. It's a lot of data to be communicated to one central unit. And that's why we need to make things decentralized. For the same reason, computational limitations. Even if we would be able to have the bandwidth to communicate to one central unit, it would most likely be too much data to handle in one at one computer cluster. So this would also need to be decentralized. So there are, of course, several methods, but just to collect at very high level, there are 4. So the first 3 here is use something like a clustering, where you maybe allow devices to communicate between each other. They're not allowed to communicate their private data outside this cluster. So what they do is that they train a model for this cluster that is actually able to generate data output. This is in turn communicated to the outside world in the network, and then is used to enhance the data of other local agents or devices. There is also methodology based on perturbing data. For instance, say, this is just an example. We have data and predictions based on age, name, and gender, and say the names are pretty common, but once you know their age and gender also, you will be able to identify them. What you can do is that, for instance, you remove and say also where they live. So you remove some parts of the data and you communicate it centrally, and it will anyway provide information, although you have actually removed some information, to not be able to identify who is behind the data. And you can do it because it's actually how recommendation systems work. You typically have perturbed and incomplete data. And then there is methods based on so-called few shots learning. So it could be that we have some data donators. So there are some people who donate their data and say, yes, you are free to build a model. What you can do is that you use semi-learning. So you build a model that can actually take a new input data, even if it's very few data, and be able to generate or predict a behavior in a fairly correct way. And probably maybe some of you have seen some generated videos of moving heads and talking faces. where a model is based, and then you take just one single picture and feed in the model, and that model is able to generate a moving face and a talking face. So this is an example. The most challenging part is what we call fully decentralized, where actually no data exchange is allowed whatsoever. And this basically, it means that every device, every agent in the network can communicate other type of information, but not the data itself. I mean, we've heard about perturbing, adding noise. There are methodologies where you communicate a local model, etc. All these fall within this framework. And this is the avenue of research that we have chosen to follow here at AI Sweden. And the goal of AI Sweden is to take leadership in decentralized AI. It's still an open avenue of research, and there is a huge need in Swedish industry, to say the least, but also globally. The idea is that we work both with and through partners to push the technology forward. Our research group consists of researchers here at AI Sweden, but also from partners. So we work together under the same umbrella. So there is no competition. It's really about information sharing and that we help each other out. So we see AI Sweden to be a unique way of collecting different solutions, experiences, infrastructure, as you saw here, and data from various application areas. And as I mentioned, so we would like to take leadership in developing technologies in decentralized AI, especially applied to privacy preserving endeavors. And please reach out to us. You find my contact details here. You can reach me by email. And we would really like to conduct research intensive projects with anyone who would like to do it with us. Thank you.
Thanks a lot, Atir. So with that, it's up for me and Ebba to summarize this great meeting. I would like to say thank you to all speakers. It's been great performance and great working with you. And also thank you all in the audience for staying with us. So this has also been an ongoing chat where you can have a glance and you should try to copy some of the links before we close the meeting, but great effort keeping that up. So mind you, the result from this project will be posted here continuously for the coming weeks. And if you're interested in continue working with us, either Atir in the sort of more scientific sense of decentralized AI, or sort of trying and testing the Edge Lab and the infrastructure and so on, contact me, Kim, and Ebba. And also, of course, reach out to any of the speakers and participants if you would like to engage with them somehow. So with that, Ebba, do you have any final thoughts?
Yes, I think it's like really what we want to send. The message we want to send from here is that you please engage if you're interested in collaborating on any of these questions that we've raised today or new questions in relation to all of this. Reach out to us. The Federated Learning Project might be prolonged or become a bigger project, for example. So keep an eye out on AI Sweden's website, for example. We might also call to a meeting in the autumn with interested parties in kind of seeing how to move or what new projects to start or how to work continuously with these questions. But as you said, Eric, there's a lot of things still happening at AI Sweden and where different partners are collaborating on this question. So reach out and find ways where you want to look further into these questions, if it's the legal stuff or the technical stuff. But really, let's keep this discussion going and the research on these very interesting topics.
So with that, I think we should say thank you. We're on time. I'm a bit afraid of closing the meeting since we're an ongoing discussion in the chat.
Yeah, exactly. We can keep it open for a couple of minutes if you guys still want to copy some of the links or just chat away. So I'll keep the meeting open for 5 minutes, but feel free to leave if you have other meetings to go to. But thank you so much, everyone, and all the participants and presentations. Thank you so much.
Thank you, guys.